buckle up because we're diving headfirst into the whirlwind world of NLP.
NLP.
That's right.
Natural language processing. And let me tell you,
It's been a wild ride.
things have been moving at warp speed these last few years. It's like language AI suddenly woke up
Right.
and decided to go full speed ahead.
Exactly. And trying to keep up with all the new developments.
Oh, I know.
It can feel like you're trying to drink from a fire hose, right?
Absolutely. It's overwhelming, but
And
that's why we're here,
That's why you've come to the right place.
to break it all down.
We're doing a deep dive today
That's right.
into a series of LinkedIn posts by Miguel Fierro, who, let me tell you,
Oh, yeah.
this guy,
He's the real deal.
he has this incredible knack for
Yeah.
explaining even the most complex NLP stuff in a way that just clicks, you know?
It's true. And what I love is that he doesn't dim it down.
Right.
He finds that sweet spot between giving you the core concepts without overwhelming you with jargon,
And then he hits you with those, like,
and then bam,
yeah,
greatest hits of model advancement.
yes. Like, these are the things you need to know.
Exactly. Need to know, and you can tell people are loving it just by the sheer number of views on some of these posts.
Oh, absolutely. We're talking tens of thousands.
Hundreds of thousands on some. It's clear he's tapped into something that people are craving, you know?
Yeah.
That desire to really understand what's going on in AI and NLP.
Yes. It's like this whole world of language AI is suddenly becoming accessible.
That's it, accessible
And exciting.
and exciting. Exactly.
And speaking of exciting, one of the big takeaways from really digging into Miguel's posts is this undeniable rise of the transformer. It's completely revolutionized the field. But I think to really appreciate how big of a deal this is,
You're right.
we need to rewind a bit.
We need that context.
Back to the pre-2017 era when things were a little different.
Back when we were all about LSTMs and CNNs, trying to force language into those boxes.
The good old days, huh?
Well, they had their moments.
They did what they could.
But let's just say they weren't exactly built for the nuances of human language.
Right, there were like the early attempts, you know, before we really cracked the code.
Exactly. LSTMs, for example, those were great at remembering long sequences of words.
Which is important.
Essential for context.
Right, you got to know what came before to really understand what's being said.
Absolutely. But they were kind of like that friend who reads a mystery novel one word at a time. They might get there eventually, but they're going to miss all the important connections, the big picture, because they're so focused on the individual pieces.
They're so busy with the trees, they miss the whole forest.
Precisely. They struggled with parallel processing, you know,
Right, which is something our brains do naturally.
effortlessly. We grasped multiple layers of meaning at once, and LSTMs just weren't wired that way.
Okay, so LSTMs, a bit slow, a bit too focused on the details, and CNNs, on the other hand, they were all about that parallel processing, right?
That's right. CNNs were all about speed, identifying local patterns.
Like little pattern recognition machines.
Exactly. But they struggled with a bigger picture, understanding how those patterns connected over longer stretches of language.
So imagine trying to follow a movie plot by only watching a few frames at a time.
You might get the gist.
But you'd miss all the character development, the emotional arcs, the plot twists.
Exactly. All that richness that makes a story come alive.
Okay, so we had LSTMs, slow and steady, but maybe missing the forest for the trees.
Right.
And then CNNs.
Fast, but missing those crucial connections.
Enter the transformer.
Cue the dramatic music.
Yeah.
The superhero of NLP.
Miguel makes it very clear. This was a total game changer.
Oh, absolutely. The transformer revolutionized how we approach language understanding.
It's like it finally bridged that gap, right? Between understanding the small details and the big picture at the same time.
Exactly. And the genius of the transformer lies in how it does that. It balances this global understanding, seeing the whole forest, so to speak,
Right.
with the speed and efficiency of parallel processing, noticing each individual tree at the same time.
And the key to all of this, the secret sauce, is attention. Right.
Attention is where the magic happens.
It's like this word gets thrown around so much these days, but I feel like we need to break it down a bit. What does attention actually mean in the context of transformers?
You're right, it's a deceptively simple term, but it's really at the heart of what makes transformers so powerful. In the context of transformers, attention is all about focusing on the most important parts of a sentence.
Okay, that makes sense. It's like when you're reading an email and your eyes are just drawn to the key points. Right, you're not giving equal weight to every single word.
Precisely. You're scanning for the words or phrases that carry the most meaning, the ones that really matter for understanding the message as a whole.
So it's like these models have learned how to do that too.
Exactly. They've been trained on massive amounts of text data, which allows them to learn which words or phrases deserve more attention.
Because they're more likely to carry important information.
Yes. It's like the model has its own little highlighter, picking out the key parts of the text and saying, pay attention to these bits, they're the important one.
Okay, that's a great way to visualize it. So instead of just processing every word in order, it's like the model is building this map of the sentence, highlighting the words and phrases that are most closely related.
That's exactly it. It's not just looking at the order of the words, it's understanding the relationships between them, building a web of meaning.
That's incredible. So it's learning grammar and syntax on its own just from analyzing all that text data.
Exactly.
Yeah.
And this ability to pay attention to what's important is what unlocked a whole new era of NLP breakthroughs.
Because suddenly we weren't trying to force language into these rigid models anymore.
Right, we were creating models that could adapt and learn, that could actually start to understand the nuances of human language in a way that had never been done before.
And this brings us to the next phase of our deep dive, the models themselves.
The models, yes, because this one concept, this idea of attention, it sparked a whole explosion of new and amazing NLP models.
From Deberta to Bloom, the field has been transformed in just a few short years.
It's been an incredible time to be working in NLP, that's for sure.
And it all started, at least according to Miguel's timeline, with a model called Deberta back in 2021.
Deberta. Now that was a game changer.
It wasn't just a new model, it was a statement.
Right.
It was like, okay, everybody, buckle up. Things are about to get real.
Exactly. Because what made Deberta so groundbreaking was that it actually outperformed humans on a major NLP benchmark called Super GLUE.
Hold on, back up a second. Outperformed humans? Like, this AI was acing its language exams, scoring higher than the smartest people in the room.
That's exactly what happened. Super GLUE is no joke. It's designed to test a model's ability to handle a wide range of language tasks.
So we're not just talking about, like, identifying what's a noun and what's a verb. This is deep language understanding.
Exactly. We're talking about understanding the sentiment in a review, answering complex questions about a text, figuring out what someone really means when they say something indirectly.
Wow, and Deberta was doing all of that better than humans. That's wild.
It was a huge deal, and it really showed the potential of these transformer-based models. And here's another cool thing.
Okay, hit me.
This is the same Deberta that we see popping up later in Miguel's posts, in the context of Hugging Face.
Oh, right, Hugging Face. For those who don't know,
It's this awesome platform for sharing AI models.
it's like the GitHub of AI.
Exactly. And the fact that Deberta is there available for anyone to use and build upon, it just shows the impact this one model had on the field.
It's like it walked onto the scene, raised the bar for everyone else, and then stuck around to be a team player, too. I love that.
But as impressive as Deberta was, Google wasn't just going to sit back and watch.
Oh, no way. Competition in this field is fierce.
They came back swinging with their own contender.
Smith.
Ah, yes, Smith.
Yeah.
Another major development from that same year, 2021. And Smith tackled a challenge that had been plaguing earlier models. Dealing with long, complex pieces of text. You see, up until that point, a lot of these models, they were kind of limited.
Like they were trying to understand the world by reading tweets.
Exactly. And Smith came along and said, hey, let's crack open some books here.
It was like time to level up.
Right. Smith could handle news articles, research papers, even epic novels without breaking a sweat.
Wow. So suddenly we're not just talking about understanding short snippets of text, we're talking about processing information on a whole new scale.
Exactly. And this ability to process long-form text, it has huge implications for everything from scientific research to personalized education.
Oh, I can see that. Imagine getting incredibly accurate news recommendations tailored to your interests or being able to analyze massive data sets in a fraction of the time.
It's like going from reading Twitter threads to digesting entire libraries.
That's a great way to put it. But even with Smith's impressive capabilities, I have to imagine there was still the issue of speed.
Right.
We've talked about how amazing transformers are, but they're also incredibly complex, right? Weren't they still pretty computationally expensive at that point?
You're absolutely right. It's a trade-off. These models are powerful, but they require a lot of computational horsepower. But Google, being Google, they found a clever workaround.
Of course they did.
In 2021, they introduced something called the Fourier Transform Speedup.
Oh, what now?
Yeah, it's a bit of a mouthful, but basically, they figured out a way to make transformers way faster without sacrificing too much accuracy.
Okay, so less like reading every word in a textbook and more like skimming a chapter and still acing the test.
You got it. It's all about working smarter, not harder.
I like it. Efficiency is key. And speaking of massive and complex, We can't forget about Megatron Turing NLG. That absolute behemoth of a model also emerged in 2021.
Oh, Megatron Turing NLG. That was a wow moment. This thing had a mind-boggling 530 billion parameters. To put that into perspective, imagine a neural network with more connections than there are stars in the Milky Way galaxy.
It's like they built a language AI the size of a small planet.
It was a testament to just how far we could push the boundaries of model scale.
Bigger is always better.
Well, not always.
Right.
As we'll see later on in our deep dive, sometimes it's about working smarter, not just harder.
Ooh, foreshadowing. I like it. But before we get ahead of ourselves, we have to talk about Bloom, which took a slightly different approach.
Bloom, which debuted in 2022, was a breath of fresh air in the world of proprietary language models.
Okay, what does that mean? Break it down for us.
So up until that point, many of these powerful models were closely guarded secrets, developed and controlled by large tech companies.
Right, so kind of like having a secret recipe for amazing AI, but only a select few were allowed to taste it, let alone see how it was made.
Exactly. But Bloom was different. It was a collaborative effort, with researchers from all over the world coming together to create something truly special.
I love that. Collaboration over competition.
Exactly. And it was designed to be open and accessible. A model as powerful as GPT-3, but available to anyone who wanted to use it, study it, or build upon it.
Okay, so Bloom was like throwing open the doors to the AI kitchen and saying, come on in, everyone, let's cook up some amazing things together.
That's a great way to put it. It was a win for collaboration, for innovation, and for making AI more inclusive.
I love that. And this shift towards more open and collaborative AI, that's just one of the many fascinating trends that Miguel highlights in his posts.
It's true. And as we move further into his timeline, we start to see a shift from these individual model showdowns to broader trends and techniques that are shaping the very future of NLP.
Okay, this is where things get even juicier.
Right.
But yeah.
We're going beyond just the models themselves to explore the bigger picture of where NLP is headed. We're talking data quality over quantity, the rise of synthetic data, and the incredible power of prompting.
But we'll save those juicy details for part 2 of our deep dive. Stay tuned. So we've covered the rise of the mighty transformer and some of those big name models that have been making waves. But like you said, there's a whole other layer to this, right? It's not just about building bigger and badder models. It's about using them in a smarter way.
You got it. And that's one of the really interesting things Miguel unpacks in these posts. It's like a shift in thinking, this realization that maybe more isn't always better.
So unpack that a bit for me. For the longest time, it felt like the name of the game in AI was all about more. More data, more processing power, bigger models. That equals smarter AI, right?
Right, and we definitely saw that with some of those massive models like Megatron Turing NLG, the one we were talking about with 530 billion parameters. They made a huge splash, showed us just how far we could push the boundaries of model scale.
Great.
But
Yeah.
what Miguel points out, and what a lot of researchers are starting to realize, is that data quality can be just as important as quantity.
Okay, so it's not just about feeding the AI a fire hose of information. It's about making sure that information is actually valuable, right?
Exactly. And he illustrates this really well with the example of a model called Phi.
Phi, okay. That rings a bell. Remind me about that one.
So Phi was this model that got some really impressive results. But here's the thing. It did that with way fewer parameters than those giant models we've been talking about.
So smaller but mightier. How'd they pull that off?
By being really picky about their data. Phi was all about that high-quality data diet.
So it's like that old saying, you are what you eat, but for AI, feed a model a bunch of jump data, you're going to get some pretty junky output, right?
Precisely.
Yeah.
And one of the really interesting developments in this whole area of data quality is the use of synthetic data.
Synthetic data? Okay, now you're just using fancy words to make me feel lost. What is that?
So instead of using real-world text, like news articles or social media posts, to train these models, researchers are creating artificial data sets.
Oh, interesting. So it's like custom-made data designed specifically to train AI. Why go through all that trouble?
Well, for a few reasons. First, it gives researchers a lot more control. With real-world data, you're kind of stuck with whatever biases or inconsistencies already exist in that data.
Right, it's messy.
Exactly. But with synthetic data, you can create these very specific scenarios, ensure that the data reflects the parameters you want.
So if you're building a chatbot for customer service, you could generate thousands of synthetic conversations covering every possible customer question and issue.
Exactly. That way, the model is super well prepared for real-world interactions. And there's another big advantage. Ethics. Because you're creating the data, You avoid a lot of the ethical concerns that come with scraping data from the internet, where privacy is a big issue.
Right, that makes a lot of sense. So we're moving from more data is better to smarter data is better. And this kind of ties into another concept Miguel keeps coming back to prompting. This idea that it's not just about the models themselves, but how we interact with them.
It's like having this super powerful sports car, right? You might have all the horsepower in the world, but if you don't know how to handle it, you're not going to win any races.
Yeah.
Prompting is all about learning how to get the most out of these incredible language models.
So prompting is essentially about giving the model the right instructions, the right cues to steer it toward the desired outcome.
It's more than just instructions. It's about really understanding how to structure your input, how to phrase your questions, to get the most accurate and insightful responses. Like, even a simple example, asking for the capital of France.
Okay, how's that a good example of prompting?
You could ask, what's the capital of France?
Yeah.
Or you could ask, what city is the seat of government in France?
Both are asking the same thing, so what's the difference?
It's subtle, but that difference in phrasing can actually influence how the model responds.
So even small tweaks in how we ask can impact the results.
Exactly. And as these models get more and more sophisticated, the techniques we use to prompt them are evolving too. One of the things Miguel talks about is chain of thought prompting.
Chain of thought prompting. Okay, that sounds intense. What is that? It's actually pretty cool. It's this idea of guiding the model to break down complex problems into smaller, more manageable steps. Kind of like when you're learning math and the teacher tells you to show your work.
Oh, I get it. So instead of just spitting out an answer, it's like we're asking the AI to explain its reasoning, to show us how it got there.
Right. And by making the reasoning process more explicit, it can actually help these models arrive at more accurate and reliable solutions, especially when you're dealing with complex multi-step problems.
It's like we're teaching the AI to think out loud in a way. And this is just the tip of the iceberg when it comes to prompting, right? Absolutely. Prompting is still a pretty new field, but it's rapidly becoming one of the most important aspects of working with these large language models. As Miguel says, it's not just a technical skill, it's about developing a deeper understanding of how these models think.
So it's less about giving orders and more about having a conversation, a collaboration. That's fascinating.
Exactly. It's not just about feeding data into a black box and hoping for the best anymore. It's about understanding how these models process information, how they learn, and how we can guide them toward more insightful and meaningful outputs.
So we've gone through a ton of NLP breakthroughs, but before we wrap up, I want to make sure our listeners walk away with those big aha moments. What are the key takeaways here?
Well, Miguel's post got so much attention because he brings it back to the human element. It's easy to get lost in the technical jargon, but the real magic is seeing how these breakthroughs impact our lives.
So if you had to distill it down, what are those core ideas that every listener should hold on to?
I'd say there are three major things to remember. First off, the transformer is a total game changer. It's the foundation for pretty much all of modern NLP.
Right, like we can't overstate that.
Absolutely. If you get even that basic idea of how it uses attention to focus on what matters in language, that's huge.
Yeah, it's like having a mental roadmap to navigate this crazy AI world we're living in.
Exactly. And the second big takeaway, bigger isn't always better when it comes to these AI models. For a while, it was all about cramming in more data, but
Bigger doesn't mean smarter if you're just feeding it garbage.
exactly. Data quality can be just as important, if not more so.
It's like the difference between reading a carefully curated library versus just a random jumble of internet comments. You might find some gems in the chaos, but...
But that library is going to give you a much deeper, more reliable understanding.
Perfect analogy. And the third takeaway that I think is so crucial is about how we interact with these models, prompting. It's not just a technical skill set. It's about learning the language of AI.
It really is. You have to learn how to have a conversation with these incredibly smart, but sometimes very literal-minded machines.
It's not enough to just know the right commands. You have to understand how to guide it, provide context, really steer the AI towards the insights you're looking for.
It's like learning a new language. And as Miguel emphasizes throughout those posts, that's where the true power comes in. It's not just about using these tools, but really understanding them.
Right. It's like the difference between just driving a car versus actually knowing how the engine works. You can get from point A to point B,
But that deeper knowledge, that's what lets you optimize, troubleshoot, really unlock the full potential.
And that's the challenge to our listeners, right? It's not enough to just keep up with the latest NLP trends. You have to go deeper. Move beyond just using these tools to truly grasping how and why they work the way they do.
Exactly. Because when you have that deeper understanding, you're not just along for the ride. You can help steer. You can shape how this technology evolves.
That's a powerful thought to end on. So to everyone listening, we've only scratched the surface of this NLP world, but hopefully this has sparked your curiosity. Now go out there, explore, keep learning, keep asking those big questions, and who knows what you'll discover.
I couldn't agree more. This is an exciting time to be interested in language AI, so dive in and see where it takes you.
And on that note, thanks for joining us on this deep dive into the fascinating world of NLP. Until next time.